A1 Tutor live class and welcome to the mathematics class. Today we are going to take a new topic. We've concluded the topic we are treating before, which is matrix, and today we are taking a new topic. So perhaps if you did not join us for the live session for the topic matrix, you don't need to panic. All you need to do is to visit our YouTube channel and have access to the video for matrix. We're able to have 4 sessions in matrix, that is 4 parts: matrix part 1, part 2, part 3, part 4. So all of it is available on YouTube. You can do well to search YouTube, A1 Tutor, search for A1 Tutor, then you have access to that. Watch the video and enjoy learning. So today, we are going to start a new topic, like I said. And as our usual way of doing it, we first need to introduce the concept by explaining what the topic entails to us, relating it to our real life activities. Now, let's dive into the business for the day. Okay, let's say this is a scenario we are going to use to introduce the topic for the day. I'm traveling within the town of Lagos. So I'm actually in this bus called Danfo. Of course, you know, in Lagos, we call this bus Danfo bus. So I'm part of the passenger. I'm part of the passenger in this bus called Danfo. So this happens to be the conductor. Should I call him the conductor now? The one collecting the money from the passenger. So this is the conductor. This is the conductor, and this remains the driver, and these are the passenger. So unfortunately, we entered the Danfo, the bus, and I told him I was going to Yanapaja. That is where I was actually going to. So we sat down. He told us, "Oh, my people, the tip fare to where you are going to is 500 naira." He said the tip fare is 500 naira. All right. So we all sat and we're all moving to our destination. I missed the journey, or along the way while we are still going, the conductor have to just call the attention of everybody, like you see in the picture, that hey, you people wait till the tip fare has changed from 500, now it is 700. You can see he's pointing his hand at the price, that the tip fare now is 700. So which means we are no more paying 500. If you are lighting, you'll be paying 700. Whereas when you came into the bus, he told you it is 500. Now he's telling you that it is what? 700. What is the reason? He said there is increase in the fuel price. So because of increase in the fuel price, it has to also lead to increase in the transportation fare. Now, what you observe, there was a change from 500 to 700. Now, the rate at which the money increase is what we call change in price over change in time. Change in price over change in time. So that can be represented as this change in price, let's say P over change in time. So the price change because there was a change in the tip fare change, because there was a change also in the fuel money within a certain period of time. It is subjected to a period of time. So the change in price over the change in the period of time at which you enter the bus is called the topic of today: differentiation. Differentiation. So differentiation is defined as the rate of change. Differentiation is defined as the rate of change differentiation is defined as the rate of change. So the rate of change is called differentiation. I enter the bus, seated, moving to my destination. You said the transport fare is 500. Within a twinkling of an eye, you said the transport is 700. Why? Because there was an increase in the price of fuel. So you too, you are going to be collecting 700. So look at that rate at which the money increased from 500 to 700. So that is called differentiation. So that is the real life applications of what? Differentiation. This is one scenario. We are going to use another scenario to explain again how differentiation is applied to our daily activities. I believe this is clear to us before we take the next scenario. If yes, please thumbs up or drop a message in the chat box. So let's take another scenario again and explain how differentiation is applied to our daily activities. How differentiation is applied to our daily activities. Okay, now let's make use of this. Of course, we are all familiar with this. We are all familiar with this. It's loading. We're going to have another explanation. Wow, we have it here now. Now, this is another real life application of differentiation. Now we have someone here. He was actually checking his phone and he was marveled. Wow, what is happening here? That means something has happened. There has been a change. Now we are going to explain that also. This young man bought data. You know, we all use data. You know, we said data is life. So you need data to access the internet. You need data to browse. You need data to go through the social media. So he bought data of 8 gig. Of 8 gig. He used it the first day. It was remaining probably 5 gig. And he used it the next day. That is on the third day now. And he noticed that the data remained 3 MB, 3 megabytes. You know, he was not shocked that how? How will 5 gig reduce to 3 megabytes? 5 gigabytes reducing to 3 megabytes. How? The question is that what has happened is what we call the rate of change. The rate of change. The rate of change happened to the data, which was 5 gig, and it is now left with what? 3 MB, 3 megabytes. So the rate at which our data decreases when we use it is called differentiation. It's an application of what? Differentiation. It's an application of what? Differentiation. So these two scenarios that I brought to us give us the clear understanding of what differentiation is all about. Differentiation is defined as the rate of change of a particular event, the rate of change of a particular process, the rate of change of a particular activities, or the rate of change of a particular motion. So it encapsulates the meaning rate of change. Rate of change. So when you hear the word differentiation, it means the rate of change. So next time when you see your data is actually reducing, you don't have to panic. What has happened to your data is what we call differentiation, the rate of change. Of course, you are not expecting to be using your data and still want it to be the same way it is. No, there will be a declination in the data, and that is the rate of change. That is the rate of change. So today we are taking the topic differentiation. That is the topic for today. Differentiation is a topic under calculus because calculus has two branches. It has differentiation and integration. But today we are considering calculus, but the focus is on differentiation. Differentiation. Okay, so let's start the class proper now. We're going to start with limit function. Limit function. If you are with me, please kindly signify with a thumbs up. We're going to start with limit function, like I said. All right, limit function. The topic again we are treating is differentiation, and a subtopic under it is limit function. Limit function. This is a topic you cannot actually escape in UTME. It comes every year. It comes in a large number of what questions. So you need to understand the topic very well so that when you come across it in exams, you can answer it accurately. So today we are doing differentiation, and we started with the first one, which is limit function. Now, what is limit function? We're going to go straight into the solving. I need to tell you the tips, the hints, and the tricks in solving a limit question. You know, Jamb, you don't need to waste your time. You have to be fast about solving it. So you need to know some hints, some tricks, or some what? Some strategy to know how to go about your limit function question. Now, what are the things you have to observe? The things you have to take note of. Number one, when you are given a limit function question and you have the following responses I'm going to write now, the answer is classified to be undefined. If I have a question of limits and after solving, I have 0 over 0, this is called undefined. It is called undefined. If I have number 2, if you solve a question under limits and you have a constant over 0, e.g., 1 over 0 or 2 over 0 or minus 4 over 0, all this is also undefined. Undefined. Okay? If you press this on your calculator, you are going to see something like syntax error or math error. A constant over 0 is math error on your calculator. So when you have answers like this also in limit function, we say it is an undefined response. Another one is when you have infinity over infinity or infinity. When you have infinity over infinity, or probably your answer is infinity, it is also classified to as undefined. It's also classified to as undefined, or for some subject, for some textbook, they call it infinity. But this is what UTME knows it to be. They know it to be undefined. So when you have all these responses, you cannot actually leave it like that. You need to apply another method so that you get a particular answer. You must get a particular answer, a particular response. So I want you to take down these three tricks, these three hints to identify the undefined questions. Take it down, and we are going to have some examples to solve from UTME right away. So I want you to take this down. Probably you write it or you take screenshots so we can proceed. So if you have done that, please signify by giving a thumbs up. If you have taken the screenshot, please signify by giving a thumbs up. All right, so let's dive into solving question with those tricks now. I said it, take notes, this topic is coming every year. You cannot escape it. So please be attentive as we are trying to make it more simplified. Be attentive, all right? So let's have it. The first question under limits. I'm going to wipe the board. Still solving the question or the subtopic limit function. Limit function. I'll be taking the first question. The question is limits x tends to 2 when you have x squared minus 4 over x minus 2. Okay, so this is our question, and we are all going to solve it together. Now, what we have here is what we call a limits question. Now, when you have limit x tends to 0, I pronounce this arrow as tends to 0. x tends to 0. But the question we have is x tends to 2. Now, what it means is that anywhere you have x in your question, replace it by 2. This is the question itself. So anywhere you have x in the question, you replace it by 2. So I'm saying that x squared minus 4 over x squared minus 2. I'm to replace x by 2 because I was given 2 here. So it means you are saying x equals to 2. So anywhere you have x, just replace it by what? 2. So let's do that. It's going to give us 2 squared minus 4 over 2 minus 2. That is 4 minus 4 over 2 minus 2. The answer is 0 over 0. So what do we call 0 over 0? What do we call 0 over 0 under limits? I need your response. You can type it quickly. What do we call 0 over 0 in limits? In limit function, what do we call the response? 0 over 0 is called what in limit function? I need your answer in the chat box. Yes, I'm waiting for your response. 0 over 0 is classified to be what? We've just treated it not quite long now. 0 over 0 is classified to be what? I need your response. 0 over 0 is classified to be what? Okay, the answer is undefined. I said it in the tricks that when you get 0 over 0, 0 over 0, you get it to be undefined. It means it is undefined. There are answers that when you get, naturally, you should know that it's going to be undefined. 0 over 0 is part of it. Also, if you get 1 over 0 is also undefined. Infinity over infinity is also undefined. Ordinary infinity also is called undefined. Okay, so please take note of that. We have discussed that before some of us joined the class. So we said all of these are classified to be undefined response. So now that I've been able to discover that the solution is undefined, I'm not going to leave it like this. I need to solve more and get a particular answer. So what will I do? Now you're going to use your factorization knowledge. Your factorization knowledge. I have x squared minus 4 over x minus 2. So applying factorization, applying factorization, applying factorization, this is going to be x squared minus, I can also write 4 to be 2 raised to power 2. If you agree with me, 4 also is the same thing as 2 raised to power 2. Then everything is x over 2. All right? So we keep on solving. Now, this x squared minus 2 squared is what we call difference of 2 squared. In mathematics, it is called difference of 2 squared. And this is the general formula of difference of 2 squared. It is a squared minus b squared. It's going to give you a plus b, a minus b. That is what we call difference of 2 squared. The difference of 2 squared. So I'm going to apply it here. Let's say this is a and let's say this is b. So difference of 2 squared for this expression is going to be x plus 2, open brackets, x minus 2, all over x minus 2. So when you have that, you'll be able to see that some particular response can cancel each other. X minus 2 cancel x minus 2. You are left with x plus 2. You are left with x plus 2. Now, what is x? You come back to your question. X is what? 2. So it means 2 plus 2. Now the answer is what? 4. So the limit is what? 4. After applying the what? Factorization method, the accurate answer is the limit of that question is what? 4. I believe you get that. So you are always going to test first, naturally, without doing anything. When you get 0 over 0, then you apply another method to ensure that you get the answer. And for this question, we later applied what we call the factorization method. I believe this question is clear to us. If yes, please kindly signify. Kindly signify or drop an emoji or drop a message in the chat box. Can we proceed? All right, okay. So let's proceed to have another question. And this, I want you guys to cooperate by also engaging the question from your own end. All right? Permit me to wipe the board, or you have not written it. If you have written it, type yes. Or you have taken a screenshot, type yes in the chat box. If you have written down the question, please type yes. All right, okay. Thank you for your responses. Now let's take the next question. The next question under limits. The next question, they are still under limit function. Limit function. Okay, let's say we have limits x tends to 5, x squared plus 5x minus 10. Limit this question. Solution. You should know that I said when you hear the word limit, it means that here x is equals to what? 5. That's the meaning of this expression. X is equals to 5. Meaning that anywhere we have x in the original question, you replace it by what? You replace it by 5. So we are going to have x squared minus, or sorry, plus 5x minus 10. That will now be 5 squared plus 5 bracket 5 minus 10, which is 25 plus 25 minus 10, which is 50 minus 10, and final answer is 40. Final answer is what? 40. Is that clear to us? If it's clear to us, signify. Then quickly, you are going to do this for me. Limits x tends to minus 1 when we have x squared minus 2. X squared minus 2. If the second example, which is this, if it is clear to you, please kindly signify or type yes in the chat box. I'm waiting for your reactions. All right, so please solve this now. Solve this for me now and give me your answer. Solve this now. I'm expecting your response. Solve this question right away and give me your response. This question, solve it now. And for those of us following on YouTube, if this is the first time you are following us, please ensure that you subscribe to the YouTube channel so you can have notifications of our videos as we upload them. Okay, and also this question here that I asked the live class students to solve, it's also for you. So do well to also solve this question and drop your own response in the comments section on YouTube. Drop your answer in the comments section. Solve the question and drop your response in the comments section. Do we have anybody with the response now so that we can proceed? Do we have anyone with the response for this question? Do we have anyone with a response to this question? If yes, please type the response in the chat box. Okay, let me help you out. So to solve this is not going to take us time. All I need to do is to introduce that my x is equals to minus 1. That's the meaning. So if I have x squared minus 2, it means open bracket minus 1 all squared minus 2. And minus 1 all squared is equals to 1 minus 2, which is the 2 I have there before. Subtracting this, my answer is minus 1. So the limit for that question is minus 1. The limit is minus 1. The limit for that question is minus 1. I hope that is clear to us. Okay. All right. So let's proceed. I'll be dropping evaluation question after the class. So do well to practice it. Okay. So let's proceed now. That is limit. That is how limit will come to you in the UTME exam. All right. That's how they will bring a question concerning limit function in the UTME exam. Now let's take the next subtopic, which is differentiation. Differentiating with respect to x using the general formula method. Differentiating with respect to x using the general formula method. Differentiating 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 using the general formula method. Now you need to understand this general formula method because you'll be using it for other methods as we proceed in this topic. So I'll take my time to ensure that I explain it in details, and I want you guys to follow. And if I ask you to do any of it from your own end, please do well to do it, and feel free to drop your answer in the chat box or the comment section. I have a n, or let me say ax raised to power n. Let's say y equals to this value. If I'm going to differentiate, that is, I'm looking for the y, the x. That's the meaning of differentiation. Change in y over change in x. You know, we defined from the beginning of the class that differentiation is the rate of change. Differentiation is the rate of change. So change in y over change in x, that is change in y with respect to x. That is why it is called the y dx. Y is here, x is here. So we call it the y dx. The y dx. To solve this, it's very simple. Please follow closely and attentively. The first thing you need to do is to use this n to multiply a. That is a times n. I'm taking it step by step. Use the power, which is n, to multiply a. That is a times n. What next? Write the x that you have there before. That's this x. Then write back your n and subtract 1. Subtract 1 from it. So if I multiply an, I'm going to get an x n minus 1. Let's say we have it as a normal question. 4x raised to power 2. Let's use this. Or let's use raised to power 3 for a start. The y dx of this is going to be 3 times 4. What is 3 times 4? 3 times 4 is 12, right? 3 times 4 is 12. Then you have your x there. What is your power? Your power is 3. then you take away 1. Using the general formula, this is the general formula. You always subtract 1 from differentiation. Subtract 1 from the power. In differentiation, we always subtract 1 from the power. We always subtract 1 from the power. So this will give us 12x raised to power what? Raised to power 2. Do we get that? If yes, please signify so I'll be sure that you get it. Okay, good. Now, if you get it indeed and you're actually sure, I want you to do this for me very quickly. This is going to give me the boldness that you've gotten how to differentiate a simple expression in this topic. So let's say I have minus 4x raised to power 2. What would be your answer? What would be the y, the x? Quickly. What would be the answer? For our people on YouTube, please, this is a question for you. So take a pause, solve it, and let's see what your answer will be. Drop your answer in the comment section. Of course, I'm going to solve it, but I want you to pause now and solve this question for me. Differentiate this and let's see your response. I'm waiting. In few minutes, I'm going to solve it. Few minutes, I'm going to solve it. So I'm waiting for you guys to solve it. I'm waiting. Time is counting. Your time is counting. Are you ready? What is your response? To differentiate this should not take you more than a minute. So what is your response? This is the question, Basi. This is the question. The question is what I circled. So I want you to solve it and let me have your response quickly. If I'm going to solve this, it won't take me more than a second, or let me say more than a minute, and I'll be done with it. Differentiate what I've circled. All right. If I'm going to differentiate this, I'll take 2 and multiply minus 4. That is minus 4 times 2. Then I will have x 2 minus 1. Minus 4 times 2 is minus 8. Taking away 1 from 2 is 1. That means you have x raised to power 1, which is the same thing as minus 8x. Minus 8x. Minus 8x. So that will be the response. I've solved the question. I've solved the question already. So let's say I have another question again, that y equals to 8x raised to power 4. Can you help me out with this one? This is the question here. I've circled it in case you can't see it. That's the question. Can you help me out with that question? It should not take you a minute to solve it. All you need to do is just to multiply, then subtract, and you are good to go. If you are on YouTube and you are following us, this question also is for you. Solve the question when y equals to 8x raised to power 4. Find the y, the x. 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 Waiting for responses. Waiting for responses. Okay, let me solve the question now to save our time. So I'm asked to find the y, the x of this question. I'm going to have 8 times 2, 8 times 4 rather, that is 32. 32 is not the final answer. 32, then I will have x raised to power 4 minus 1. General formula, you have to subtract 1 from your power. You have to subtract 1 from your power. So this will give us 32x raised to power 3. 32x raised to power 3. 32x raised to the power of what? 3. 32x raised to power 3. I believe that is clear. If yes, please let me know. Okay, I want to give you another question right away now, and I want everyone to solve it and send them answer quickly. Quickly, I want to be sure that you understand this. This is the basic of differentiation, and we need to understand it first before we can move on to other methods. All right, so let's take two more questions, and I will need your response to be fast and quick. Y equals to 6x raised to power minus 3. Very fast one, very fast one. Y equals to, this is question 1. Question 2, y equals to 3x raised to power 7. Very fast one. I need your response. This is your question. I need your response. Solve this and drop your answer in the chat box. If you are watching us on YouTube, solve this question. Find the y, the x. Find the y, the x. Find the y, the x, which is also known as the derivative. So if you are watching us on YouTube, this is the time you are watching us and you are having this question on the screen. Take a pause, solve the question, and drop your answer in the comment section. Y equals to 6x raised to power minus 3. Find the y, the x. Y equals to 3x raised to power 7. Find the y, the x. I'm waiting for your response quickly. I'm waiting for your response quickly. That should not take us than a minute to solve. A minute to solve. A minute to solve the question. Okay. So the first one. Question number 1. I said y equals to 6x minus 3. The y, the x equals to minus 3 times 6. Minus 3 times 6. Minus 3 times 6. Minus 3 times 6 is minus 18. Minus 18. I want you to get it right. When you do this, you don't just stop like that. You have to write the x again. The x should be coming back here. Then you write the power again, minus 3. It is from the power that you remove 1, not from your answer. It is from the power that you remove 1. So I'm going to say minus 1 from the power. From the power. The general formula is an x n minus 1. N is your power. So we are going to have minus 18x minus 3 minus 1. That is the power. That is minus 4. Minus 18x raised to power minus 4. Minus 18x raised to power minus 4. So this will be the answer. I leave this for you to solve. Solve question number 2 and drop your answer in the comment section on YouTube. Drop your answer in the comment section on YouTube. I believe now you have understood how to differentiate with respect to x. I believe you have understood how to differentiate with respect to x. So do well to solve this question and drop your answer in the comment section on YouTube. So today we started a new topic, a recap of what we have done today. We started a new topic, which is differentiation, and we're able to introduce the concept. We said differentiation is the rate of change. The rate of change. We used 2 scenarios to explain that, the concept of differentiation. After that, we went ahead to study or to examine limit function. Limit function. And now we ended the class with differentiating with respect to what? X. Differentiating with respect to x. We are going to stop here today, and next class we are going to continue. This question I gave you, question number 2, I want everyone to solve it and drop your answer on YouTube. You just need to search for A1 Tutor, A1 Tutor, then search for the topic differentiation part 1. It will be uploaded this evening. Once the video is uploaded, you go to the video, watch it, and under the video, the comment section, you drop the answer for this question. For this question. So I need your response on YouTube. I need your response on what? YouTube. So do well to drop your response on YouTube. Thank you for your time. I want you guys to stay online. We'll be having the next class in a few minutes' time. So stay online. Biology class will start very soon. Thank you for being attentive and thank you for your time. Bye. See you in the next few minutes' time.